Hi, so before you start watching the video and listen to the tutorial, I'd like for you to pause the video actually and try the problems on your own. Now you can do that a slide at a time, or you can try to do the entire packet on your own and then go through and watch the video. I would think it's more effective to try a slide, press pause, then press play again and watch me explain the slide. So the first one here, after you read the directions, it says to determine which pairs of angles or sides would have to be congruent. In the first scenario, to use angle, side, angle. Now, this problem means that I gave you some information already. You're given that AC and CE are congruent, and you're also given that these two angles are congruent. Now, I don't tell you, nor do I mark it at first, but you know that those are definitely true or congruent because of vertical angles. So, knowing that this is my given information already, let's see, what would have to be congruent for angle, side, angle? Take a minute to think. The answer would be angle A would have to be congruent to angle E. Look at the order of the information. So I'm going to erase that so that I can have a fresh palette to look at for the next one. It said the triangles would be congruent by angle, angle, side if, well, in this case, angle B would have to be congruent to angle D. Let's go to the next one. You can pause and try this on your own. Okay, so it says the triangles would be congruent by side, side, side if, well, let's look at what's given first. So I'm given JO and OV are congruent, and I'm also given that OA is congruent to itself. Okay, so side, side, side would have to work if, well, I need a third side, right? JA would have to be congruent to AV. This picture is not drawn to scale. So if that were true, then I'd have a side, side, side. The last one, it says SAS. Well, look what I'm given. Again, I was given JO and OV. I was given OA because of the reflexive property. I don't have to show it, I don't have to mark it, but I know it's congruent. For side angle side, it'll have to be the included angle. Now again, this picture is not drawn to scale, so they don't look perfectly congruent, but they are. Now when you name this angle, if you said angle O, I would mark it wrong. You would have to say angle JOA is congruent to angle VOA. You could also just number them, and if you wrote angle 1 is congruent to angle 2, I would also accept that. Okay, so this one says, can the triangles be proven congruent? So let's see what's given. Here I'm given these two sides are congruent. I'm given this reflexive piece, so I'll go ahead and mark that. And I'm also given that these two sides are parallel. Well, if I look closely, if they're parallel, then I have alternate interior angles. I didn't even have to be given anything else. I can see that this is going to be side, angle, side. So yes, SAS. If I look at the next pair of triangles, well, I notice that they have vertical angles here. But wait, here you have angle, side, angle. Here the order of the given information is angle, angle, side. Remember, for these postulates to work, they have to match between the two triangles. So this one is a no, okay? It can't be proven. If I had more information, perhaps I could, but no, this can't be proven based on what we have right now. I'd like for you to try this proof. You can press pause, or you can watch me explain. Okay, so where's my given? Next thing, let's look at what's given. So until MA is parallel to IE. Okay, so if that's true, then let's first highlight these parallel lines. And if I look, I have one transversal here, which would mean angle M is congruent to angle E. That's because if lines are parallel, that means alternate interior angles are congruent. Let's also look at another thing in the picture. I noticed that I have vertical angles in this picture. Well, because of that vertical angle theorem, I can say angle, let's say angle ADM is congruent to angle IDE. If you said angle D is equal to angle D, I would mark that incorrect because D is the vertex of multiple angles. You cannot name any angle in this picture angle D. If you notice, I could call these M and E because they were the only vertex that referred to those angles. Okay, so let's keep track. It says D is the midpoint of AI. So AI is this segment. If D is the midpoint, that means that AD is congruent to DI. That's definition of a midpoint. And then for this last one, well, if I look at the order of my given information, I have two angles and a non-included side. That means that triangle MAD is congruent to triangle EID by angle side. Okay, so this video was to cover things referring to our postulates. You can turn to the next video to talk about isosceles triangles.